2 years ago, I posted a video about IGMP Snooping and IGMP Querier for UniFi switches. At that time, the UniFi controller setting is very simple. You simply enable it or disable it. All other features were hidden in the CLI for switches. But today, if you go to UniFi network controller, you can see this multicast filtering setting. If you enable it, then you will see a lot of features which didn't exist in the past. I am going to have multiple videos to cover the settings. In this video, we are going to see IGMP Snooping in action and then focus on the IGMP Querier settings. In my lab environment, I have a UXG Pro as the gateway, then 4 UniFi switches, 5 devices. I'm going to use one device connected to the first switch as the multicast video source, and then 3 other computers, Windows or Mac, connected to different switches as the multicast video receiver. Then I have a totally separate Windows device. It won't be a video source or receiver. It will do its own business. Let's see in this environment how the multicast works and how IGMP Snooping works. On the screen, I show you 4 devices. The top left will be the multicast source. I'm using VLC media player in this video for the multicast. Let me start a stream. I'm going to use one of my own videos. Here, let me set up the streaming. I'm going to use RTP. I'm going to use this address. Later, you will know this is a multicast address. I accept the default port. Apply. Stream. You can see now the time is changing, which means it is doing the multicast. But we cannot see anything because we haven't started receiving the video yet. In the 3 remaining devices, let me start the VLC receiver. Open network stream. This URL is RTP protocol. The multicast address I just used in the first device, and then the port specified in the first device. Then play. Okay, see it start playing already. Then move on to the second receiving client. Open network. The same URL. Open. Then the last receiving client, the same way, file, open network, the same URL, open. Okay, so now you see all the 3 clients, they are playing the same stream. If I move the progress bar in the source, you will see all the 3 clients, they will refresh the change. Okay, so far so good, right? But behind the hood, the network is super busy now. At this moment in UniFi network controller, the multicast filtering setting has the default value, which is disabled. Remember, I'm only showing you 4 devices here in this screen. They are really doing the multicast either source or destination, right? But if I move to the 5th client, remember I mentioned there is a Windows machine, it won't be participating in this multicast video thing, right? So let's move on to that device. This is the 5th client. It seems to be a very quiet situation, right? But if I launch a Wireshark, start capturing Ethernet port and filter on UDP, you can see it is receiving floods of UDP packets. See what's the source? 1.139. If I show you this diagram, you can see this is the IP address for the multicast source, right? Then see what's the destination. Destination is the multicast group address I specified when I start the streaming, right? This is the situation for this particular 5th device. It has nothing to do with the video. It doesn't want to be part of the streaming, but it has to deal with so many packets. It has to throw them away. It will waste the computer's resource, waste the network bandwidth. So this is just the harm for this particular device. Think about the network for any other computers or devices which are in the same LAN. They will be impacted. All the UniFi switches are flooding the UDP packets to all the network ports, no matter whether the devices need them or not. So that's the problem of multicast if you don't do anything about it. Now let's talk about IGMP IGMP Snooping. Let me go back to the 4 devices which are doing the streaming. I already launched Wireshark in all of them. As you can see, in the 4 Wireshark sessions, they are all receiving tons of UDP packets. But if I change the Wireshark display filter to IGMP, nothing. If I choose a random client, for example this one, then go back to VLC player. So I just resumed the playing, right? So you can see what happened. This device sent out a IGMP membership report to which group? Multicast address I specified when starting the streaming. From which device? From this particular Mac computer. Then if I close the window, see what happened? The same device sent out a leave group IGMP message. This type of membership report or leave group message, they are both part of the IGMP messages, but at this moment they are not really used by any network devices. The reason is we haven't enabled IGMP snooping yet. We are missing an important type of device, multicast router. IGMP stands for Internet Group Management Protocol. IGMP v2 is popularly supported. It is used by IP hosts to report their multicast group memberships to routers. So here it talks about 2 different types of devices, host and router. In the demo I just did, you see the video server and the video clients. They are hosts, so they communicate using the UDP multicast traffic. We see them using Wireshark by filtering the packets. We also see sometimes they send out IGMP packets, but nobody process them because we are missing local multicast router. By the way, in this video, I'm only going to talk about IGMP within the local network. So this diagram is extremely simplified. UniFi switches, as long as they support IGMP snooping, they can act as local multicast router. Don't be confused when you see the term router. Here it is not talking about the UniFi gateway. It is simply referring to multicast router. An UniFi switch can act as an IGMP router. It is a multicast router that uses IGMP to manage multicast group memberships on a IPv4 network. In the previous demo, you already see 2 types of IGMP messages, the membership report and the leave group message. But in this video, we will focus on general query message because one of its main usages is to elect IGMP Querier in your network. You may have multiple UniFi switches in your network, but only one of them can be a IGMP Querier. In order for IGMP and IGMP snooping to function, a multicast router must exist on the network and generate IGMP queries. IGMP Querier plays a very important role in the IGMP snooping. Let's go back to the lab environment to see it in action. As you can see, I have stopped all of the 4 VLC players activities, and for each Wireshark, I have the same display filter applied. Of course, I only want to see IGMP, right? But why I want to filter the destination IP address to this strange IP address? Now it's time to talk about multicast address. In this Wikipedia article about multicast address, it lists the IP blocks for multicast address. There are some individual addresses. They are special, so this article lists them out separately. You can see here in Wireshark, I filtered using this particular address. What's this one? It is called all hosts multicast group address, and sometimes it's also called all systems 224.0.0.1. So this IP address is used in general query IGMP messages. That's why I want to filter on this IP address just to make our investigation easier. Then let me go to UniFi network controller. Now multicast filtering is disabled. Let me enable it. All of the computers are in default default network. So let me only enable the multicast filtering in default network, save. And then you can see there is a function which is related to Querier, but now let me leave it default without touching it for now. Apply changes, then go back to the for Wireshark sessions. After a while, the Wireshark still hasn't captured anything because now we don't have any active IGMP multicast activities. Let me go to VLC player, start streaming again. Okay, I see the first general membership query and see where it is from. The source is this particular IP address .1.202. See this lab environment diagram. .1.202 is for this enterprise PoE switch. This is strange because I have 4 UniFi switches, and this particular switch, it is not the closest one to the gateway, and it doesn't have the smallest IP address. So later you will know why I want to stress on the smallest IP address. But for now, I already see issues because now I only see this particular switch send out the general membership query, which means now this switch is the query, but it shouldn't be. I will explain why. But for now, let's park this issue aside because in the second half of the video, we are going to focus on the troubleshooting of the Querier election. Now, let's see some good news. Remember, we just enabled the IGMP snooping, right? Let's see the effect. In the 4 computers that were doing video streaming, I stopped the streaming already and restarted Wireshark, only filtering on UDP. As you can see, the network is pretty quiet. There's no video streaming going on. Now in the first computer, let me start the video source. Start. Okay, so you can see it start playing already, and then you can see the busy UDP packet from this computer to that multicast group, right? The difference if you compare to previous cases, see the other 3 computers, they remain calm. There are no same busy UDP packets. The network activities for these 3 computers are not impacted. Why? Because we have enabled IGMP snooping. You see the effect already. What if in this VLC media player, I start streaming, open the recent media, the same URL. See, now you see the same packets as the left side and you see the video started, right? But the other 2 computers remain the same. Then let me quickly start them as well. Start and start. Okay, so now you can see all the 4 computers, they are busy. That's expected. What about the 5th computer? Remember in previous case, it's greatly impacted. It was minding its own business, but it also received tons of UDP packets, which it never asked for, right? You can see I'm showing the 5th computer. There's no busy UDP packets at all. This computer remain unimpacted. Okay, I believe it's enough to show you the benefit and effect of IGMP snooping. It's time to go back to the issue about IGMP Querier. In the demo case we just saw, the 3 video clients, they send out membership reports. But who manage those received reports? Who decide the switches forward the UDP packets to which client? That role is taken by a IGMP Querier. The IGMP Querier will maintain the complete tables about IGMP members and their corresponding multicast groups. In my lab environment, there are 4 UniFi switches, but in this local network, there should be only 1 active IGMP Querier. But remember, we only enabled IGMP snooping. We didn't set anything about Querier. Then the question is how the system even come up with a Querier, how the election process works. Based on IGMP standard, I draw this simple diagram about the the multicast router state. It's a very simple, very straightforward, but also very effective election process. It is supposed to work without any need to configure anything. Every multicast router, or in my case, every UniFi switch, will start from the initial state. So when a switch will be initial state, for example, you just rebooted the switch, or you just changed the IGMP snooping setting from the initial not enabled option to enabled IGMP snooping. Once you apply the changes, the switch will be in initial state. Okay, at this state, the switch is supposed to send out the general query. Then the switch will immediately become a querier, which means there should be a very short period in my local network. There are multiple queriers because all the 4 switches are supposed to automatically become queriers when they send out the first initial general query, right? But don't worry about that, because once a switch believes itself is a querier, it will send out the general query periodically, because a switch will also receive other switches' general queries. The switch will compare the IP addresses. If the general query it receives has lower source IP address, the switch will automatically become a non-querier. The switch with the lowest IP address is supposed to be elected to be the final active querier. So when a switch is a non-querier, it doesn't mean it will give up, because in each query there's a timer. If the timer expires, the switch still hasn't received any queries from other switches which have lower IP addresses than itself, it will become querier again. So in this very supposedly effective way, things should work amazingly. But apparently it's not the case in my UniFi local network. Remember, when I enable IGMP snooping, one and only one switch, which is the Enterprise 24 PoE switch, only this one send out the general query, and then it becomes the querier forever. I didn't see any general queries from any other switches, which didn't make sense, because according to the IGMP protocol, it shouldn't behave in that way. Let's do further investigation. To find out more information which is not available on the UniFi network controller user interface, let me SSH into the 3 different UniFi switches. So first, the Pro 24 switch. I'm in, then telnet to itself, en for enabling, then config. Okay, now I'm in the config mode. For the Enterprise 24 PoE switch, in the exact same way, let me go to the command line. For this small PoE switch, it's not part of the Pro or Enterprise product lines, but for historical reason, it also supports very similar command line, even though the way to enter the configuration mode is slightly different. Let me SSH into it first. Then instead of running telnet, let me directly run command CLI. Okay, I'm in the same command line interface, then en config. Okay, so now I'm ready to see what's the current IGMP query situation. So the command I'm going to run is show IGMP snooping querier detail. So let me leave it there for now. Move on to the second switch, run the exact same command. Okay, the third switch, the same command. Okay, now let's try to understand what's the return information. So see the USW Pro 24 switch. As indicated in the diagram for the 4 switches, this switch has the lowest IP address. According to the IGMP protocol, this switch should be elected as the querier automatically. But what we observed was different. The Enterprise switch was elected, right? And then from the command line output, you can see for VLAN 1, remember we enabled IGMP snooping for default network, which is VLAN 1. See the operational state, it is non-querier. Then for the Enterprise switch, for VLAN 1, it is querier. For the small PoE switch, it is non-querier. This confirms what we observe in the Wireshark, right? But why is that? I already saw multiple problems, but let's first talk about this one, the Querier VLAN address. This one is the one we talked about during the Querier election process. Each switch will check the general query's source IP address. That source IP address is not really the IP address for the switch. In fact, it is internally maintained separately. Here in the command line output is called Querier VLAN address. So let me use one general query IGMP message as an example. See, for this one in Wireshark, it shows the source is this IP address, which is the enterprise PoE switch, right? The destination is the multicast destination for the general query. However, from backend, we can see another IP address, the so-called Querier VLAN address. For this enterprise PoE switch, the Querier VLAN address, it is all 0. So the first problem I see is for this Querier VLAN address, all the 3 switches, they are showing all 0 IP address. It doesn't look right. So let's see how we can change it from the UniFi network controller. Just to make a fresh configuration change, let me first disable the IGMP Snooping setting, apply changes. Then in the for Wireshark sessions, I restarted the capturing and the filtering on IGMP. Now you can see there's no any IGMP messages, which means now there's no IGMP query in the network at all. Then go back to the network controller. Let me enable it again. Still select default network. Then see there is a setting here. It is create new Querier switch. Just by reading this text, you may think, okay, it seems you don't have to rely on the automatic Querier election. You can directly specify a Querier. But is that really the case? If you move the mouse cursor to the eye, you can see a sentence which gives you no new information at all. It's such a typical Ubiquiti so-called help information. It doesn't really provide any help. And in many cases, it even makes the understanding more difficult. Okay, let me ignore it. Let me proceed. Create a so-called new Querier switch. It says the network default. Okay, I don't want to change it. For switches, see, I have the drop down. I can select any of the 4 available UniFi switches. Let me select the USW Pro 24, right? Because I really want this switch to become the Querier. So then it comes to another confusing setting. It's called Querier address. If you try to see the help, again, it only says something we all know, but we still don't know what's the purpose of this setting. Even more confusingly, it has a alter option. So we will explore what this means exactly later. But now let me try to accept the default setting, hoping this configuration will make the USW Pro a Querier switch. So let me create it. It seems to be what I want. Let me apply changes. Then let's go back to the 4 Wireshark sessions to see what will happen. After a while, we do see several IGMP messages, and by reading the destination column, I can see only this one. It is the general query. Unfortunately, the source, it is still the enterprise switch. Remember in the UniFi network controller, we only added the Pro 24 switch as the query, right? Because from Wireshark, we don't see any change at all. Let's see whether from SSH, from the command line, we see any difference. Okay, I just rerun the same command, show IGMP Snooping query detail in all 3 sessions. It seems nothing's changed, but if you look into them very hard, there is one and only one change. It's here, the Querier VLAN address. Only for this Pro 24 switch, the Querier VLAN address is not or 0 anymore. Now it's 0001. The other 2 switches, they remain or 0. So why we have this change? The only possible reason is in UniFi Network Controller, we added this Pro24 switch in this Querier switch setting. It explains what this function is at all. If you add a switch to the so-called query switch list, it will give the switch a non-zero IP address. So we can prove that by adding more query switches here. So now we only have the Pro24, right? So let me add all the other 3 switches, the Enterprise 24, then add the first small PoE switch, then add the second one. So now I have added all the 4 switches. For now, I still keep the query address as author. Let me apply changes. Then from the Wireshark, let's see what will be the change. Give it some time to reflect the switch configuration changes. Okay, now in the Wireshark sessions, do you see any interesting new things? There are some packets from this strange source IP address, and they are general membership query, and the destination is the correct multicast group. But why the source address is such kind of strange thing? We don't have devices with such strange IP address because we still don't know what this device is at all just by reading the IP address. Let's try to see what's the MAC address. So see, the MAC address, the source is Ubiquiti, which means it is from a Ubiquiti switch. And if we read the last 3 numbers, 93, 4E, F5, then we go to UniFi Network Controller. We go to the devices. If you check the enterprise switch MAC address, no, that MAC address we just saw is not this enterprise switch. Then is it the Pro24 switch? No, it is not. Then is it the first small PoE switch? Yes, it is 934E F5. So which means all of a sudden, after we added all the 4 switches to the Querier switch list, this small PoE switch became the Querier. So the situation is even messier. Let's look into the backend. Okay, in the 3 SSH sessions, I have re-executed the same command, show IGMP Snooping Querier details. Let's first check the small PoE switch. See, operational state, it is Querier. That confirms what we observe by checking the MAC address in Wireshark, right? And see all the 3 switches, they share the similar change. See, they all have non-zero VLAN address now. For the Pro24 switch, it's 0002. For the enterprise switch, 0001. And for the small PoE switch, 0004. Why they all have non-zero address now? Because we just added all of them to the query list in UniFi Network Controller, right? Then the next question, why they have this type of strange but seems to be sequential number? Why? Because when we add them to the list, we keep the query address as author. The so-called author means the system will give them non-zero address, but the system will not use their original IP address. The system will automatically assign an address based on whatever logics it has. I hope it's clear for you why now all of a sudden the switches have the strange Querier VLAN address. But I don't like this type of author assignment because it will only make my troubleshooting more difficult. I want the multicast routers to have their original IP addresses as the Querier address. Here, I don't want to see 0002. I want to see this .1.201 IP address. How I can do that? I simply go to the UniFi Network Controller. I assign the addresses to the individual switch here. So let me do that. For this switch, uncheck author, give it its original IP address as the Querier address. Do the same thing for the other 3 switch. Okay, now if I check the query address column, I'm much more comfortable. I can see the familiar IP addresses. So let me apply changes. Then go back to Wireshark. So now you can see after a while, the IP address which sent out the general query is changed. Now it's showing the IP address for the Pro 24 switch, right? So which means our changes to the IP addresses work. Additionally, now the Pro 24 switch is the Querier. It seems what I want to achieve has been achieved because now the preferred Pro 24 switch, which has the smallest, lowest IP address, is acting as Querier. Is the problem resolved? No. The reason is I don't see the query election process. Why is that? Because I only see one switch, which is the Pro 24 switch, sent out the general query. Theoretically, for the query election process to work, I expect to see the general queries from each single switch. They need to compete with each other. They need to elect the query, right? But I don't see the process. I only see all of a sudden, for whatever reason, this Pro 24 switch randomly became the query. I'm still not comfortable. Let me see what really happened. Why there's only one switch which sent out the general query instead of all of them. In the 3 SSH sessions, I already refreshed the show IGMP Snooping query detail command output. So we can see for all the 3 switches, they have the desired query VLAN address as we specified on the UniFi network controller. And this Pro 24 switch, it is the query, right? But there's one thing still catches my eyes. It is here, VLAN election participate mode. It is disabled for the Pro 24. And for the other 2 switches, the same thing. They are all disabled, which explains why the expected query election process didn't happen, right? Here is my theory. I believe there is still a bug in the Ubiquiti's implementation. When we add switches to the query switch list, one thing is missed in the Ubiquiti's implementation is the system should have automatically changed each switch's query election participate mode to enable. Because this is not done, the election process didn't happen. So to prove my theory, let me manually change this election participate mode to enable. Let's see what will happen. Let me clean up the Wireshark captured packet first so that we can start from scratch. Okay, I have cleared the previously captured packets. Now let me go back to the SSH sessions. To change this participate mode, I need to go to the VLAN mode. From the prompt, you can see now it's in the general config mode. So I need to exit this mode, then go to VLAN database. Now I can configure the changes to each VLAN. Let me run this command. The 1 means VLAN 1 default network. So basically what I'm saying is I want to enable the query election participate mode for default network for this particular switch. But before hitting enter, let me type the same command in the other 2 switches because I want to make the change effective at almost the same time for the 3 switches. So for the other 2 switches, let me do the same thing. Okay, I typed the same command. Then let me execute the command in the 3 switches. Done, done, done. Okay, now let me go back to the general configuration mode. Now you can see for all the 3 switches for VLAN 1, their election participate mode are all enabled. Okay, then let's go back to Wireshark. See, now the IGMP messages are much more busier. So from each switch, see here, from 201, the Pro 24, 202, the Enterprise switch, 203, the small PoE switch. From all of them, I see the membership query. That happened right after I enabled their election participate mode. They send out the general query. But after a while, see which switch became the final querier? This one, the 201, which is the Pro 24 switch. Why is that? Because this switch has the lowest IP address. Okay, only at this moment I am completely happy with the result because I do see the querier election happened. Unfortunately, you may know this type of change from switch is not permanent. If you reboot the switch or you got the firmware upgrade, the changes you make in the CLI will be lost. The only hope is, if my theory is correct, if it is a bug from Ubiquiti, I hope they will change their implementation so that in the future, every switch will participate into the election process. Okay, this is the end of the video. Thanks for watching.